So if you're watching this video, then you really are amazing and curious about math and geometry the way I have been for a while now. And in the last video that this is a bonus to, we were going outward and showing that here to here is 1, radical 2, radical 3, radical 4, and radical 5, radical 6. So each circle's radius or diameter is the proportion of 1, radical 2, radical 3, radical 4, radical 5, radical 6. Now what if we go inward? And we continue to do this and draw the circle inside. So we're going to come up with an interesting pattern, and I mentioned it in the last video. I just wanted to show and prove it mathematically. When we go inward, we're going to get radical 2 over 2, the proportion of that, which I think again is amazing. Then we're going to get 1/2 if we go inside it again. Then we're going to get radical 2 over 4. Then we're going to, if we keep going inside more and more and more, we're going to get 1/4, then radical 2 over 8, then 1/8, radical 2 over 16, 1/16. So you could probably see the pattern by now. The next one will be, what do you think? Radical 2 over 32. So we alternate between the radical 2 over 2 and then the whole number 1 over 2. And then what we end up doing is we continue that pattern, but the bottom one gets multiplied by 2. So I wanted to show how that works. For example, let's say we had this orange one as 1. So really we can represent any one of these as 1. So if this is 1, then the one up next, the one above it is radical 2. And then radical 3, radical 4, and so on. But let's say this is 1. And we want to find, well, what would the radius be of this inner circle then? We want to go inward. And we don't know it, so we'll call it x. However, we know that this radius is the same all the way around. So straight up here is x, and this is the same distance, x. So here, 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 and here we have a box, just like in the last video, only we were going outward. And in the last video, we were looking for the hypotenuse. When you go inward, you're going to look for the sides of the right triangle. So let's show how we would express that with the Pythagorean theorem. We would have x and x, and 1 is our hypotenuse. We would get x squared plus x squared is 1, and x squared plus x squared is 2x squared. We would divide. And then the opposite of squared is square root. We would square root both sides. So when we have the square root as a denominator, we can express this as square root of 1 over square root of 2. And we know square root of 1 is 1. So the square root of 2 we're not allowed to leave on the bottom. So we do something called rationalizing. We multiply the top and the bottom by that radical, and it moves it up. We get radical 2 over normal 2. So then, if we go in again, if we go inward one more time, we're going to continue the same pattern where now we know that the new radius is going to be radical 2 over 2, but we're going to be missing the sides again. For example, this new green circle, let me express it over here. We just found it's radical 2 over 2. And we would draw, let's see what color would be useful. I guess I'll use purple. We would draw that square around like we had done when we went outward. And so the radius here would draw a new circle inside. So we want to find that radius. We don't know what it is. It's x, and going up it's x. But again, we know that the hypotenuse of it is radical 2. So here's what we're looking at. This new hypotenuse is radical 2 over 2, but we don't know the sides. So we would do that same Pythagorean theorem. we get once again 2x squared. Radical 2 times radical 2, this is radical 2 over 2. Radical 2 times radical 2 is normal 2. 2 times 2 is 4. And we can express that as 1/2. So now we have 2x squared is 1/2. We can multiply both sides by half to get rid of the 2 there. So x squared is equal to 1 over 4. We square root it. And that's the same as square root of 1 over square root of 4, so we get 1/2. So we can continue this, this pattern, right? We had 1 radical 2 over 2. Now we have 1/2, 1/2. And we'll continue, we'll do the Pythagorean theorem again. So now, so each time we go inward, the last number we just found, which was 1/2, use the same color, becomes the hypotenuse. And we keep repeating this Pythagorean theorem. The two sides are going to be the radius of the new circle. And we're going to get 2x squared is 1/4. We'll multiply both sides by half. And we'll square root both sides. Square root of 1 on top is 1. And then square root of 8. I'm not going to get into a lesson of reducing square roots, but this is going to be 2 times 4, so radical 4 is the same as 2. Radical 2 left over. And once again, we're going to rationalize by multiplying the top and bottom. So the bottom becomes 2 times radical 4, or 2 times normal 2. So the bottom becomes 4, and the top becomes radical 2 over 4. And then, now that is our hypotenuse, radical 2 over 4. And we can just continue this pattern. So 2x squared is going to equal square root of 2 over 4 squared. I added the 2x squares just to save a second. 2x squared is going to be normal 2 over 16, or 1/8. We'll multiply both sides by half. So x squared is 1/16. And when we square root it, square root of 1 is 1. Square root of 16 is 4. So we're beginning this pattern, and you could continue this process if you'd like. It's simply going to alternate, starting with 1, then it's radical 2 over 2, then 1/2, then radical 2 over 4, then 1/4, and then radical 2 over 8. So the question is, do you believe me? I'll go ahead and I'll do it one more time. Now we have radical 2 over 8 as our hypotenuse. X squared plus x squared is 2x squared. Radical 2 over 8 squared. 2x squared is radical 2 times radical 2 is 2. 8 times 8 is 64. This reduces to 1 over 32. We multiply both sides by half. Remember what's supposed to be next? 1 over 16. So let's see. 32 times 2 is 64. We square root both sides. And the square root of 1 is 1. The square root of 64 is 8. And sure enough, it continues that pattern. So the next one is square root of 2 over 16, and then 1 over 16. Square root of 2 over 32, 1 over 32. Square root of 2 over 64. But I don't know who would really use those particular ones. I know square root of 2 over 2 is a very common one on the unit circle. And maybe you'd use square root of 2 over 4 if you were constructing something. But, you know, moving inward, we get this repeating pattern of square roots and then fractions, and I think it's pretty interesting. So thanks for sticking with me, and if you have any questions, let me know.